Yes, guys. So today I'm taking question for the lecture series 13, in which I have taken property of triangles. Now, property of triangles will have a lot of things. I mean, how we have to solve the triangles. After that, I'll take solution of triangles. And in case of solution of triangles, we have to find out if three sides or three angles are given, and find the other things, or two sides and one angle is given, then find the other sides of the triangle. So that means solution of the triangles. Okay, so in this way we will find out how the area is to be calculated, what is the formula for area. Now we have to find out what is sine and cosine formulae for solution of triangles or properties of triangles. All these formulae, which are very important for this all kinds of students who are studying trigonometry, and they have to encounter with these questions on one time or the other. Every time they have to just have to face these questions again and again. So these questions are taken, identities are taken, trigonometric identities, and they are related to the triangles. So because of that, this is the property of triangles. How property of triangles are being described. I've taken almost all kinds of these properties. I mean these identities, in which I'll take afterwards I'll take areas of the triangles, but before that let me take some basic formulas, sine and cosine formulae, which are based on property of triangles. Now this is very much required identities, and they are one of the most important topic here in trigonometry. In trigonometry one has to know about all these formulae, shortcut formulae, and they are to be applied to solve the problems. The solution of problem, first of all we have to understand how these identities are to be derived, or they are driven, how they are derived. The derivation of these problems, these sine and cosine formulae, tangent formulae, cotangent formulae, all kinds of formulae are noted down here. Here are some multiple of angles, some multiple of angles, some multiple of angles, and multiple of angles. Multiple of angles, some multiple of angles, or single angles. We have to take all these formulae, which are very much related to the solution of triangles, property of triangles, sine and cosine formulae, tangent formulae, all kinds of formulae. Let me take. Now let me take one by one. First is, what is a sine formula? Whatever sine formula, let me take this first. So sine formula, question number one I'm taking. Let me describe all these. How sine formula is taken. Now, so far as triangles are concerned, there are three kinds of triangles. One is acute angle triangle. Second is obtuse angle triangle. In which at least one angle is obtuse angle, or a right angle triangle, in which one angle is right angle, other two are some of the right angle. Other two angles, sum must be equal to right angle or 90-degree angle. So in right angle triangle, one angle is right angle. In obtuse angle triangle, one angle is obtuse angle, others are acute angles. But in acute angle triangle, all the three angles are acute angles. So first I'll prove that how in acute angle triangle, the sine formula, which is A upon sine A equal to B upon sine B equal to C upon sine C. This formula is applicable. So sine formula, let me first write what is sine formula. Sine formula is known as sine formula. Sine formula is described or written as A upon sine A is equal to B upon sine B is equal to C upon sine C. How it is derived, let me talk about that. How this formula is verified, how this is calculated, that let me take one by one. Solutions we are taking to solve this formula. First let me take first case, or case number one, acute angle triangle. Acute angled triangle. Triangles, this is symbol for triangle. Let me write a triangle. Please just try to understand this is symbol for triangle. I'll note down this symbols number of times. So writing triangle in letters. Instead of that, we apply this symbol for writing the triangle. So triangle ABC. So acute angle triangle. So let us take let us take an acute angle triangle, or okay, let me take an acute angled triangle ABC. Let me take. What is acute angle triangle? This is the acute angle triangle in which all the angles are acute. Acute means acute angle means less than 90 degree. Each angle is less than 90 degree, but some of them, or all of these, some of these three angles is equal to 180 degree. That we know about. Properties of triangles we know about that. Some of this, let me take A, this is B, this is C. Some of these three angles, angle A plus angle B plus angle C, is equal to 180 degree. This is geometrical concept known to us very much. Okay, basic fact of triangles: the sum of all the three angles of a triangle is 180 degree. That we can prove, but that is not required at the moment. Only the formula we have to prove. So what we do, we consider the side opposite to these angles as small a, small b, like this. Let me take the side opposite to angle A is A. That means BC is equal to A, and side opposite to angle B is this. This is B side. Okay, and side opposite to angle C is this side. AB is equal to, let us say, acute angle triangle ABC, where ABC is equal to A, the side opposite to the angle A. Similarly, AC is equal to B, the side opposite to angle B. Side opposite, this is length of the side AC, which is B, equal to B, opposite to the angle B. And this AB is equal to C, again the side opposite to the angle C. This is symbol for angle, so angle C. So all this is basic things required. So that I have written down now. Now let me take then how we have to proceed ahead. After this bit information regarding the sides and angles of the triangle, this acute angle triangle. Okay, let us say we draw a perpendicular. If we take a perpendicular AD, this is D point here. Okay, the side, length of the side is okay, this is A, but this point is D. Let me take. So we draw perpendicular, or draw AD perpendicular. This is symbol for perpendicular to BC. That means this implies that angle ADB is 90 degrees. Similarly, angle ADC and angle ADC is also 90 degrees. This is because AD is perpendicular to this. Now let us say a right triangle ABD. In a right angled triangle ABD, we have, now there are basic things which we have to know about, that in any right triangle, when we consider an angle like this B angle, it be considered. So sine of angle B, this equal to perpendicular upon hypotenuse. That means equal to AD upon AB. AD upon AB, which is equal to AD upon AB is C, small c. This implies that AD is equal to C into sine B. This is, let me take equation number 1. Alright, equation number 1. Now, in right triangle ADC, and in a right angled triangle ADC, we have, what do we have? This is AD upon AC. Again, perpendicular. The side opposite to the angle is perpendicular. Which angle we are considering is perpendicular. This AD is perpendicular. AD upon AC in this right triangle. Okay, AD upon AC is equal to sine C, or sine C equal to AD upon AC. Or this implies that sine C is equal to AD upon B. This is length of the side AC, which is B. So we have written down AD upon B is equal to sine C. Or if I cross multiply, this implies that AD is equal to B into sine C. This is second equation. What do we see from first and second? From first and second, what do we see? Let me write down here. So from equation from first and the second equations, we have, what do we have here? Now here AD is C sine B. Small c sine B is equal to B into sine C. B into sine C. Or this implies that this B upon sine B. B upon sine B equal to small c upon sine C. If I just divide this C by sine C and B by sine B, and B upon sine B is equal to C upon sine C. This is third equation. Okay. Similarly, we can take, okay, if I just change the denomination of this triangle, let me take now, let me change the denomination of this. What is that? Divided, this is ABC, let me take. Now from C we have dropped a perpendicular, this is side C. Now AB is C. This is A here. Now side opposite to angle B is B. Okay. Now in this case, this will be B upon this CD upon. So now in right triangle, so we get here. So we can get from this triangle ABC. Now ABC we have just changed the denomination. Now we can also prove in terms of A I'm talking about, that if I take this right triangle, then this is again B into sine A. This is B into sine A. B into sine A. Why? Because AD is equal to, this is equal to AD. Why? Because, sorry, CD. I'm sorry, this is CD here. CD upon CA is equal to sine A. CD upon CA, CA is B. Upon B, if I take, let me take B here. Sine A is equal to CD upon CA. CA is B here. Okay. Or this implies that CD is equal to, this is in the right triangle, CAD. So CD is equal to B into sine A. And in the right triangle, CDB or CBD. Let me take CBD. In CBD, what do we have? This sine B into A, or because CD upon, sorry, this is small c, CD. So CD upon, sorry, this is CD upon CB or BC is equal to sine B. Now CB is A or from this let me take CD upon A is equal to sine B, or A sine B. So CD, from this we have obtained of CD is equal to A sine B. From this CD was B sine A. So from this let me take, this is the fourth one, this is the fifth one. Okay, now in this case this is B sine A is equal to A sine B. Okay, so we can just take that B upon sine B is equal to A upon sine A. So this is, let me take the sixth equation number, by the fifth one, by the fourth one. So these two are combined together. If I combine them, we can obtain the same result here. So therefore, from this third one and sixth one, we get, this is the process of solving or proving the sine formula in case of acute angle triangle. So this implies that from third equation and the sixth one, what do we get? We get here that A upon sine A is equal to B upon sine B is equal to C upon sine C. This is in case of acute angle triangle. First case we have taken. Okay, now let us take second case, obtuse angle triangle. Now let me talk about obtuse angle triangle. This is the first case in case of acute angled triangle. Now case number second, case number 2 of second case. Case number 2 of second case. What do we have? Obtuse angle triangle. This is obtuse angle triangle. Let me take obtuse angled triangle. This is symbol for triangle, so let me write for complete triangle. Obtuse angled triangle. In that situation, what can be the triangle? Let me take, this is an obtuse angle triangle. If I take, let me take A, B, or this is C. If I just extend this line and draw a perpendicular from A, let me take, this is D again, right angle triangle. Now this angle C is what? This is nothing but 180 degree minus C. Why? Because this is angle C. This angle ACB is C angle. The remaining will be, total is 180 minus C. This is 180 minus C capital, angle C. This angle is in right triangle. This, if we consider, in that situation we have to take this. Okay. Now let us say, what is the angle B here? Okay, again, side opposite to this is C, side opposite to A is A, side opposite to B, this is B here. In right triangle obtuse angle triangle ABC, in which angle C is obtuse angle, and C is obtuse angle more than 90 degree. So obtuse angle, acute triangle is less than 90 degree, obtuse is more than 90 degree. That is the only difference. This is obtuse angle, more than 90 degree. 90 degree is this. This is maybe more than 90, 100 degree, 120 degree, whatever. More than 90 means, even if it is 91 degree, 90 point something, that is obtuse angle. So this is obtuse angle triangle. In this case, we have dropped a perpendicular from A, which meets BC extended at D, which meets BC at D after extension of BC. Okay, so this is, again, let us say right angle triangle please. ABD. ABD is the right angle triangle. Now, AD is perpendicular to BC, which meets BC at D after extension, after extending or extension, after extension of this or extending it. So AD is perpendicular to BC. So in right triangle, let me take, in right angle triangle, right angle triangle ABD. We have sine B. I'm taking this right angle. This is equal to AD. Now in right triangle ABD, AD will be perpendicular. No doubt about this. So AD upon this AD upon hypotenuse is AB. Okay, so this is nothing but AD upon C. This is sine B. This implies that AD is equal to the small c into sine B. Let me take this as first equation. Sine B is equal to C into sine B. This implies that this AD equal to the small c. This is small c here. The length of the side is AB. Because AB is C, small c. Therefore, AD equal to C into sine B. This is small c, no problem. Small c here. This is the first equation. Now, in right triangle ACD. In a right angle triangle, let me take triangle ACD. We have, what do we have? This value AD upon or sine this 180 minus C. Let me take sine 180 degree minus C. Sine 180 degree minus C is equal to sine 180 degree minus C is equal to AD upon AC. But AC is what? B. This is B here. And this is 180 minus theta in second quadrant. In second quadrant, sine is positive. This is nothing but sine C here. Sine capital C is equal to AD upon B, which is implies that AD is equal to B into sine C. Okay, B into sine C. This is second equation. So from first and second, equations, we have what we get. What do we get here? This we get that by C into sine B. This is small c. Sine B. C into sine B equal to B into sine C, or B upon sine B capital. Angle is capital, side is small, so notation B is small, equal to C upon sine C. Okay, this is your third equation. Let me take. Again, if I change the denomination, you will get the other condition. What is the other condition? The other condition we can get, let me write here. Similarly, we can prove that A upon sine A is equal to B upon sine B. Try to understand. You can prove this. This is suppose fourth equation. From third and fourth, this implies from third and fourth. From third and fourth equation, we get, what do we get here? That A upon sine A is equal to B upon sine B equal to C upon sine C. Simple formula for obtuse triangle also this is proved. Okay, so let me take this. Imply that A upon sine A is equal to B upon sine B is equal to C upon sine C, capital C. Okay, so this sine formula is proved in case of obtuse angle triangle. Now, third condition, or case third, in which right angle triangle is to be taken. Let us take now right angle triangle. So case number 3 was third case. Third possibility in a a right angled triangle. Right angle triangle ABC. Let me take here. This is the right angle triangle. We take this is A, this is B, C. Now here angle B is right angle. This is angle C. Side opposite to A is A, B is B, C is small c. Okay, this is right angle triangle. So in right angle triangle ABC. In right angle triangle ABC, we have sine C. Let me take. Sine C angle is AB upon AC, perpendicular upon hypotenuse. This means AB upon AC, perpendicular upon P upon H, hypotenuse. In case of sine theta, sine is perpendicular upon hypotenuse, and cos is base upon hypotenuse. This is base upon hypotenuse cos, but in case of sine it is perpendicular. The angle which we consider, the side opposite to that is perpendicular. So this is AB upon this, or sine C. AB is small c. Okay, small c here, and AC is, or we can just write that what is AB. AB in this case we are taking C, and AC. What is AC here? AC is B. So here C is equal to, small c is equal to B into sine C. This is, let me take first equation. Okay. Now if I take the angle B here, and let me write here sine of B is equal to, this is sine B angle, but sine B is the right angle triangle, is 90 degrees, which is equal to 1. Okay, so that is equal to 1. So sine B is equal to, if I write this is C upon, or this is perpendicular here, B upon, if I write it as B upon, because if I take B angle, then we can write C into, this is C upon, because angle B is here 90 degree. In case of 90 degree, if I substitute, so let me just write here. So C is equal to, in case of C we can write sine B upon, this is hypotenuse, sine B upon C, or we can write here sine B is equal to AB, which is C here. Sorry, this is B. If I take B angle here, then this is C here. In that case, this will be B upon this. Okay, so sine B will be equal to AD upon, or in this case we have taken C. C is AB. This is, let me take AB upon small c here, because this is AB is also C. This is 1. You can write it as 1 upon 1, or C upon C, sorry, which is 1 only, same value. So in place of sine 90 degree I put 1, which is 1 C upon C, because this is AB is small c. We write AB upon C. So value of AB, which is small c, we can write here AB equal to, therefore C into sine B, or AB is equal to C into sine B. Okay, AB is C undoubtedly, this is AB here. AB is equal to B sine C, AB equal to C sine B. So this is second equation, let me take. You can write from first, second, and first, or first and second. From first and second, we get here that B upon, this is B sine C, let me take here. This is B sine C equal to small c sine B. Sine B. Okay, or we can write it as A B equal to C sine B. In this case, here A B equal to B sine C. So these two, if are equated, then this is B sine C is equal to C sine B. Okay, because sine B is 90 degree angle, that means one only. This is C. We are just substituted like this. Not a problem. So therefore, B upon sine B, we can write it as C upon sine C. So let me take third equation. Similarly, we can prove. That C upon sine C. This is, let me take B upon sine B. B upon sine B is equal to A upon sine A, capital A. This is, let me take third or fourth equation. So from third and fourth, okay, B upon sine B, we can, if I change the denomination, if I take A here, B here, C here, A, B, C, then C or A can be related, okay, and value of C or sine C is this, then we can take, or either way. Okay, so from third and fourth would be C. Means from third equation and fourth, we get, what do we get here? This is A upon sine A is equal to B upon sine B is equal to small c upon sine C. So this is sine formula in case of right angle triangle. If angle B or right angled triangle, in which one angle is right angle, this is, in this case, B is right angle, we have taken, or C can be taken right angle, whatever. This is how sine formula is proved in all the three cases of pre-angle triangle, acute angle triangle, right angle triangle. Okay, this is how sine formula is to be derived. Okay, so this is derivation of sine formula. Let me take now next one. This is known as cos formula or cosine formula. The second question that we take is also very important. All these questions are very important to note it down so that one can understand that how these questions are to be calculated. Okay, because questions on the basis of these identities, further we have to find out, and for solution of those identities we have to know how to derive these formulas. That is the point.